Hi, I'm Bobby Russell. I'm a Microsoft technical trainer. I'm here to walk you through the SC200 Microsoft Security Operations Analyst course. Welcome to Learning Path 10. In here, we're going to look at performing threat hunting in Microsoft Sentinel. In this learning path, we'll cover explaining threat hunting concept within Microsoft Sentinel. We'll also look at threat hunting within Microsoft Sentinel. We'll look at search jobs in Sentinel, and finally, hunting for threats using notebooks in Microsoft Sentinel. So with that, let's go ahead and jump right into our first module, which is threat hunting concepts and understanding those things within Sentinel. After completing this module, you'll be able to describe threat hunting concepts that we use within Sentinel, as well as define a threat hunting hypothesis. So what are the steps that you would take within Microsoft Sentinel? So the term threat hunting is defined differently by different people. The most commonly used definition is the idea that you're proactively hunting through your environment for a threat or a set of activities that have not been previously detected. The not previously detected part is what differentiates threat hunting from incident response or alert triage. Threat hunting should be a continual process. When developing a threat hunting hypothesis, start by making sure it's achievable, something your team can realistically investigate with the tools and data available. Narrow the scope to focus on specific threats, behaviors, or a specific environment, which helps reduce noise and improves the precision of your hunt. You want to define a clear time frame to keep the investigation focused and measurable. You want to ensure the hypothesis is useful and efficient by aligning it with your organization's security objectives and ensuring it can lead to actionable outcomes. Most importantly, tie it back to your threat model so the hunt remains relevant to the risks you're actively defending against. Let's jump into our second module, threat hunting within Microsoft Sentinel. After completing this module, you will understand how to use queries to hunt for threats. We'll talk about saving key findings with something called bookmarks. We'll observe threats over time with something called Livestream, and we'll use the MITRE ATT&CK for threat vector analysis. Here are the steps for managing Sentinel hunting queries. Begin by accessing the Queries tab in Microsoft Sentinel to explore a library of predefined threat hunting queries. These queries are designed to help you proactively search for suspicious activity and isolated threats across your environment. Select a query to view its metadata, including things like the data source, the provider, and the associated MITRE ATT&CK process. You can execute the query directly to analyze results in real time and investigate any anomalies. For efficiency, bookmark the queries you use most often so they're readily available for you in future hunts. Microsoft Sentinel bookmarks are a powerful feature used during threat hunting and investigations to save and track important findings. When you run a query and identify suspicious or noteworthy results, you can create a bookmark to preserve that data point along with its context, such as the query used, the timestamp, and any relevant entities that are part of it. Bookmarks help analysts organize their investigations by allowing them to revisit key evidence, correlate it with other findings, and even link it to incidents. They can also be used to build cases over time, which makes it easier to document and communicate findings across the security team. To create a bookmark, start by running a query in Microsoft Sentinel to surface the data you want to investigate. Once the results are returned, review the output and identify any findings worth preserving. Use the Add Bookmark option to save these key results along with the query context, making it easier to revisit the query later. Bookmarks are especially useful for tracking suspicious activity, building cases, or sharing insights with your team. This feature helps streamline investigations by keeping important evidence organized and accessible. Microsoft Sentinel Livestream is a real-time threat hunting feature that allows you to continuously run KQL queries against live data as it's ingested. Instead of executing a query once and reviewing static results, Livestream keeps the query active and alerts you immediately when matching events occur. This is especially useful for monitoring high-risk behaviors or validating a hunting hypothesis in real time. You can manage multiple Livestream sessions simultaneously, each showing the number of matches and the time of the last result. To enable a Livestream, start by launching the Hunting Livestream feature in Microsoft Sentinel to test queries against real-time event data. As events occur, Livestream sessions actively monitor for matches and notify you when results align with your query logic. You can manage multiple queries simultaneously, each showing results counts and timestamps to help track activity over time. The interface allows you to view the underlying KQL for each query, making it easy to refine detection logic on the fly. This capability is especially useful for identifying emerging threats and validating hypotheses in real live environments. The MITRE ATT&CK page in Microsoft Sentinel provides a visual, interactive matrix that maps your detection coverage against the MITRE ATT&CK framework. It organizes adversary tactics and techniques into a structured layout, allowing you to see which techniques are covered by active analytics rules, anomaly detection, or some of your hunting queries. Each tile in the matrix represents a specific technique and is color-coded. Each tile in the matrix represents a specific technique and is color-coded to indicate the type and level of coverage. Start by navigating to the MITRE ATT&CK section in Microsoft Sentinel to explore threat techniques mapped across your attack lifecycle. Use the search bar to filter techniques by name or ID, making it easier to focus on specific tactics relevant to your environment. The matrix view displays each technique as a tile, color-coded to indicate coverage through scheduled rules, anomaly detections, or your hunting queries. Clicking on a tile reveals detailed information about the technique, including its description and how it's currently being monitored. This structured approach helps prioritize detection gaps and align your security strategy with known adversary behaviors. Let's jump into our third module, using search jobs in Microsoft Sentinel. After completing this module, you'll be able to hunt with a search job in Microsoft Sentinel, as well as restore historical data in Microsoft Sentinel. Microsoft Sentinel search jobs are a feature that allows you to run large-scale, on-demand queries across your data for threat hunting, investigations, or historical analysis. Unlike standard log queries that are limited to timeouts or resource constraints, search jobs are designed for deeper and more resource-intensive searches that can run in the background and return your results even after extended durations. You can create a search job by writing a KQL query and specifying the time range and workspace. Once submitted, the job runs asynchronously, and you can monitor its progress, view its results, or even restore the data into a table for further analysis. Start by going to the Search section in Microsoft Sentinel and selecting the appropriate workspace where your search job is stored. From there, access the Saved Searches tab to view a list of previously created search jobs, each showing metadata like the job name, the creation date, and the query used. Identify the search job relevant to your investigation and click View Search Results to analyze the data it returned. This allows you to revisit historical queries and leverage them for ongoing threat hunting or incident response. It's a streamlined way to manage and reuse complex searches without having to rebuild them from scratch. To restore historical data, in Microsoft Sentinel, begin by navigating to the Search Preview section and selecting the Restore option from the toolbar. In the Restoration panel, Choose the specific table you want to recover data from, such as the security alert table. Define the time range by entering the appropriate start and end timestamps to narrow down the data you need. Once the parameters are set, click Restore to initiate the process and bring that data back into your workspace for analysis. This is especially useful for revisiting past incidents or conducting retrospective investigations. So now let's jump into our fourth module, hunting for threats with notebooks in Microsoft Sentinel. After completing this module, you'll be able to explore the API libraries for advanced threat hunting in Microsoft Sentinel. You'll be able to describe notebooks in Microsoft Sentinel, and finally, create and use notebooks in Sentinel. When deciding how to approach threat hunting in Microsoft Sentinel, it's important to align the tool with the role and the task. Playbooks are best suited for SOC engineers and analysts who need to automate repeatable tasks like data ingestion, enrichment, investigation, or remediation. Workbooks are ideal for SOC teams and managers who need to visualize data and monitor trends through various dashboards. Notebooks, on the other hand, are designed for more advanced users, such as threat hunters, incident investigators, and data scientists, who need to perform deep dive investigations, enrich data, run custom queries, and apply machine learning or big data analytics. Each tool serves a distinct purpose, and using them together can significantly enhance your detection and response capabilities. Microsoft Sentinel is built on top of the Log Analytics data store, which supports high-performance querying, dynamic schema, and scalability for large data volumes. All Sentinel tools, including the Azure portal, interact with this data store through a standard API. That same API is accessible to external tools like Python and PowerShell, enabling seamless integration for custom workflows. Libraries such as KQL Magic and Mystic Pi make it easier to run KQL queries and perform threat investigations directly from environments like Jupyter Notebooks. Community resources, including the Sentinel GitHub repository, offer additional tools and scripts to accelerate deployment and analysis. To get started with notebooks, in Microsoft Sentinel, you'll have two main options. First, you can create a notebook directly from the Sentinel Notebooks page, which integrates seamlessly with your workspace and data sources. Alternatively, if you prefer a local development environment, you can use tools like Visual Studio Code to build a Jupyter Notebook. Both approaches support advanced data analysis, threat hunting, and automation workflows. Choose the method that best fits your workflow and technical preferences. Now that we've completed this learning path, feel free to watch some of these topics demonstrated in the following labs.
Welcome everyone to our next lab, which is going to be performing threat hunting in Microsoft Sentinel. And this is going to demonstrate what we just discussed in our presentation. To get started, what we're going to do is we need to have a device that we're going to be using for capturing logs and so forth. So I have a Windows server here, and what we're going to do is we're going to need to be able to move those logs or copy those logs from this server into Sentinel through our Log Analytics workspace so we can perform analysis. So the first thing I'm going to do is I'm going to go ahead and install this Azure Arc agent so we have the ability to perform management of it. So we're going to install this agent, and the install is going to be AZC Management Connect, which is connecting the Azure Arc agent. We're going to use this resource group. We're going to connect it to this region, and this is my subscription. So you need those three things. These are the minimum three things that you'll need to run this command. And this is going to install the Arc agent. It's going to prompt us for some credentials. So we're going to go ahead and authenticate here. And once we've authenticated, we'll get a pop-up, which you see here, window saying authentication is complete. So at this point, we can actually close that window And you'll see now that the installation process is occurring. This is similar to some of the other videos that I've shown you with the labs here, if you've been following this series. So we'll wait for this to complete. Okay, so at this point, our agent has successfully installed. We didn't receive any errors. We can also do a verification of that to verify that the agent is working. And to perform that verification, what we would do is do a AZC management, a MAGENT show. And this will let us know if the agent is successfully installed and running. And you'll see that down here that yes, it is. So everything is running good. So at this point, what we're going to do is we're going to swing back over, and now we're going to switch machines. And we're going to go back to our management machine, which is our Win1 box here. And in this machine, we're going to connect to the Azure portal. So we're going to go ahead and open up a browser here. We're going to connect to the Azure portal. And once there, we're going to authenticate. Again, we'll save the password since it's just a lab environment, because for production, I probably wouldn't. All right, so now that we're in the Azure portal, what we're going to do is we're going to connect, we're going to open up Sentinel. So I'm going to go in my search here and start typing the word Sentinel, and it'll pop up here. So here's my Sentinel. I already have a workspace pre-configured for this lab. If you don't already have a workspace, you can select the Create button here on the top left and create an instance of Sentinel. So I'm going to go ahead and connect to my instance of Sentinel here. And let's go ahead and expand all of these different areas. And what we're going to do is we're going to go to our data connectors. And in our data connectors, the connector that we're looking for, now in this lab, the connector is already installed. If for some reason you don't have it installed, you would go to your Content Hub, and from there you would install the connector. And then once the connector is installed, you would then configure it to start pulling log data. So what we're going to do is we're going to take the Windows connector, which is the Security Events AMA connector, which is here. And on the bottom right, I'm going to open the connector page. And what we need to do now is we need to configure this connector to start pulling logs from our Win server, the server that we have the Arc agent running on. Now, in order to do that, because we have the Arc agent on, we can use the AMA connector. If we did not have Azure Arc running on that Win server, we would have to use the legacy connector, which is a separate install process. But since we have it, we're going to create what's called a data collection rule. And we're going to give our data collection rule a name in this case here. So in this case here, we're going to call it AZWinDCR. We're going to pick the right subscription. The only resource group we have, we would select that. For the resources, this is where we would find that machine. Now, assuming everything went well, which it did, there is the machine right here. So there's my machine. So the Arc agent worked, and it is reporting that machine. So we're going to pull the logs from that machine. Now, as we've mentioned in previous videos, you do have the ability to filter which logs you want. But for this demonstration, we're just going to pull all the security logs from that server, and we're going to create this rule. So now the data collection rule has been successfully installed, configured, as you can see in our notifications here. So the next thing we want to do is we're going to simulate an attack. Now, in order to do this, what we're going to do is we're going to go back to the Windows server that we have the agent installed, and we're going to do a few things here to generate some simulated attack traffic as part of this. So let's go ahead and open up Notepad here. And what we're going to do is we're going to run a script. The script that we're going to run is this right here. It's just some code that we're running here to simulate an attack. What this code is going to do, it's going to simulate DNS queries to a command and control server, basically. We're simulating a malicious threat in this scenario here. All right, so what we're going to do is we're going to save this file, and we're gonna save it as c2.ps1. We'll save it into our documents here. All right, so we're going to save that, and now what we're going to do is we're going to execute this script. So let's go ahead and open up PowerShell here. So we're going to run that script. So let's go ahead and find that script here, and let's go ahead and run it. So I saved it to my documents. So there it is right there. We're going to execute this script. And if you notice here, it has given me an error, and that is perfectly normal. We're using this just to essentially generate some traffic here. So the errors, you'll see it as it constantly tries to resolve. Notice here it's trying to resolve certain domains and so forth. And it's basically simulating an attack as part of this. So now, while this is running, let's go back to our management server that we have the Azure portal currently on, and let's start the hunting process, which is the goal of this demonstration here. So what we're going to do is we're going to go in and we're going to go to our Sentinel main page. So within the main page of Sentinel, we're going to go to the log section. Now, keep in mind that depending on how your connectors are configured, it may take a few minutes for log data from various servers and other sources to make its way into your log analytics workspace for Sentinel to use. But we're going to go ahead and test this out here, and we're going to run a quick query that's going to look for that specific thing. So what it's looking for here, by the way, we've got a variable set up here. If you're not familiar with KQL, watch our KQL video that we in one of the previous modules here. But we've got a variable statement, which is going to set this to 2 days. We're looking in a specific table, and the table that we're actually looking at here is going to be the security event table. And within that table, we're looking for events that have happened within a period of time. We're looking for this event ID and this PowerShell command being run. And then we want to see the output here in this specific order. And again, in our KQL class, we do cover this a lot more detail, but let's go ahead and run this. Okay, so at this point, we have not seen anything run yet, and the reason for that is we're still waiting for the log. So let's look at how we would troubleshoot this to make sure it's running. So first of all, let's go back to our data connector page under our navigation screen here, and let's go to our AMA agent. Let's go ahead and open this up. One of the first things that I want to point out here is, if you notice, the status is still disconnected. What this tells me is that this agent, this connector, has not received any data from the agent. And that's because it's still relatively new. We just installed it. So we're going to give it a couple seconds here, a few minutes for it to update the status, and then we'll go back to our query. Okay, so now I've just refreshed the page, and you'll notice that the status is now showing connected. So the agent is running properly. As part of that, we haven't received any log data yet, as you can see here, but this should start flowing in shortly. Now that we have that, let's go back into our main page, and let's try running this query again here. So we're going to go into our logs. I'm going to turn this off because I don't want this popping up every time. I prefer the regular KQL mode. It gives me more options. Some people may be more comfortable with the simple mode. And let's go ahead and rerun this query. By the way, now I know that it should run properly, and here's why. Because I'm looking at my table view, which this lists all of my tables. Now, this is not the tables. Those are the categories. But if I go in here, there you go. You can see the tables. Now that the table is in here, that tells me that the Log Analytics workspace has received data because it creates the table when it receives the data. So we're going to query that security event table. So that's the table we're going to query, and we're going to look for this specific information. So let's go ahead and run this now. And we still don't have anything. We'll have to give it a little bit more time. Let's go back to our connector. Let's see if it's receiving any data yet through the connector. And this is something that you definitely want to keep in mind when you're setting these up in production, that it does take time once the connector is enabled for it to show us connected as the status, as well as for data to start being received. We've run the query where we're looking for it. Keep in mind, the connector is up and running, but it could still take a while for the data to show up as part of this process here. So keep that in mind. It could take quite a while for this to show up. So that's an example of one of the queries that we can run. Again, there's additional queries that we do have the ability to run here. I can go in here. Again, it's all KQL, Kusto query language. So here is an example here. So now we're starting to get log data in. So you can kind of see what the results are as part of that there. So this is what we should see. This took about four or 5 minutes in real time for this to start showing up. So if you are trying to do this in your own personal labs, just give it a little bit of time. It will, assuming everything else is working properly, this will show up. So you see all of the data within there. It's showing, and as I continue to run this, it'll increase, and you'll see more and more as the connector reports more data. You'll see more lines in your output here, more data coming out. So now what we're going to do is we're going to go in and we're going to take the data from this query and we're going to add a bookmark to it. And this is going to be a neat little tool that you'll be able to do. You give your bookmark a name, and in this case here, we'll just call it the security event number. The event time mapping, we're going to use now as the option for this one here. We do have an option for add a new entity. So we're going to add a new entity here, and the entity that we're going to specify is going to be the host. So we're going to add the host, then we're going to add the host name, and when it comes to host name, we're going to specify the computer. So we're going to add that in there. As far as the tactics, so what we're doing here is essentially we're saying, okay, based off of this query, this is the output. I want to bookmark this. I want to save this output for later analysis if I need to, maybe for training purposes. And I give it a name. I specify what it's tied to. So we're looking at a host, a specific host as part of this. The type of threat in this case here would be your tactics and techniques. So in this scenario, the tactics and techniques that we're using for this, let's say it's command and control. So someone is trying to do something with DNS to try to gain command and control capabilities. So we're going to go in there, we're going to save, we select create, and it saves that bookmark. And we'll show you a little bit later on what you can do with that bookmark. But now we've got the output of that saved for further analysis later on. So now what we're going to do is we're going to go ahead and close the logs that we've had. And now we're going to go into the hunting section. So within our Sentinel environment, we're going to go to hunting. And in hunting, remember I mentioned that you can see the bookmarks that you've saved. So under hunting, you'll see this bookmark section here. And if you notice, there it is. It's showing the event data, the results of the query, and so forth. So now we can use this for further analysis if we need to. But what I'm going to do is I'm going to go in and I'm going to create a brand new query. Now, you may be wondering, well, what is hunting? Hunting is a little bit different than analytics. When you run analytics queries, these are queries that you're going to run on a schedule normally. I run them every 5 minutes, every hour, every 5 hours, every day. Or if you do a near real-time query, every 2 minutes. But it runs on a constant schedule. In hunting, this allows me to create and save queries that I can run on demand whenever I want to. So to do that, in my hunting page, I'm going to go to queries. And within queries, what we're going to do is we're going to create a brand new query. And in this query, we're going to call this PowerShell Hunt. I don't need a description, but I'm going to put a description here, PowerShell hunt, just because. And then the KQL query that we want to run. Remember, everything we do is KQL. So this is the query that I'm going to be running as part of this here. Now I'm going to add some additional things. For my entity mapping, I'm going to add, again, I want to know the host name. So give me the host. I need to know the host name. And again, we're going to go with computer as our options as part of this here. So now, similar to what we had before, our tactics and techniques, let's go ahead and make this one command and control. And we're going to save this. We're going to go ahead and click create. So now you'll notice that in my hunting page, so under hunting, under queries, there is my hunt. So now what this basically is a KQL query that I can run on demand. So whenever I want to run it versus it being on a schedule. Most of your queries will be schedule based because you want it to run automatically, but there may be certain hunts or certain queries that you want to run just whenever you need them, but it's not necessarily something you care about running on a consistent schedule. For those, you can just put them in here. And essentially, what you would do is you would select the hunt query that you want. So in this case, PowerShell hunt. I select that from my list. And then what I can do is I can go in. There's a couple things I can do here. On the far right, I can run it. I can add it to my favorites. I can modify the query. I can clone it, delete it. I can create an analytics rule, which means I can now schedule it to run constantly if I want to. I can add it to a live stream. Live stream, basically, it runs back to back to back to back. It doesn't stop until you tell it to stop. Typically, we run live streams when we're troubleshooting something, and I want to know as soon as it's resolved. I want to know. In that case, I would run it as a live stream. So I'm going to go ahead and add this to the live stream just so you can see. So there's my PowerShell hunt, and if you notice, it's running. And it's going to run, and as soon as it finishes running, it's going to run again and again and again. This is real-time results. And when I'm done with this, I do have the ability to go in, and I can pause it so I can run it later on, or I can delete it. Keep in mind that when you delete a live stream, it does not delete the query, the hunt, it just deletes it from the live stream page. So you can go in there and add it to a live stream for consistent or continuous running. Another thing that you can do with this is, let's say I do want this to run on a schedule. I have the ability to go into it and create what's called an analytics rule from it. And it'll fill in all the things that I've already completed. It'll include the query data. There's my query. In this case here, I can say, well, because it's a scheduled rule, I can specify how often I want it to run. So maybe I run it every 5 hours if I want to, or, the minimum you can do is every 5 minutes. You can't go any lower than 5 minutes. And the maximum is 14 days. So I can run it once every 14 days. I can run it every 5 minutes, but it's anywhere in between that range that I want. So I would fill in that, let's say the rule finds a match. I can then have it open up an incident for me, which is like a ticket within Sentinel. I can have it automatically respond. And then finally, assuming let me fix this here. Let's bring that back to 5 minutes. And assuming everything else is fine, it's going to do a validation. And assuming everything's good, I can now save it. So now what has happened is my hunt, which I was doing on demand through the hunting option, is now an analytics rule that runs on a clearly defined schedule, which is every 5 minutes in my case here. So it's going to be in my list of queries that I have here that runs continuously as part of that process. Hopefully you enjoyed that piece. There's one more thing that I want to show everyone here, and then we're going to end this part of the video. And that piece is the MITRE window. This is something that's still in preview. It's been in preview for a while here, but this is a great tool. And what I want to do is explain to you exactly how this works. If you are a security professional, a SOC admin, SOC architect, SOC engineer, or anything related to security where you're going to be doing this, this is a great tool because what this does is it takes the MITRE ATT&CK framework, a process, and each of the sub processes on how. So for reconnaissance, how can reconnaissance happen? Through active scanning, through gathering victim information, from gathering org information, phishing information, and so forth. And what this does is it, and I'll explain to you how this is broken out. For reconnaissance, there are 10 different ways that people can, threat actors can initiate a reconnaissance attack. They're listed here. If you notice, none of these boxes are highlighted or filled in any way, unlike this one here and this one here and so forth. This is a very useful tool. Here's why. If the box is not shaded in, that means you currently have nothing within Sentinel that's designed to look for these types of attacks. So you have blind spots in your security posture. Now, if you look at, let's say, execution, with execution, you see this number 6. That means there's 6 things within my Sentinel deployment that look for command and scripting type of attacks. And if you want to know what those 6 things are, you can select the box, and on the right here, it will show you. So it's telling me that I've got 3 query rules that are running on a schedule. I've got 2 near real-time rules, and I've got an anomaly rule that's running that can be used to detect this attack. If I look at my, exploit, let's look at domain policy modification. There's one thing I currently have configured, which is an anomaly detection rule that looks for that. For brute force, we've got 5 schedule queries. So there's 5 queries that are in my analytics page here, my analytics window here, that are designed to look for brute force attacks. And then also, there are 5 anomalies, 4 scheduled, and then 5 anomaly rules that are configured to look for that. So your goal in life as a security professional is to make sure you have at least one number in every box. You want every box shaded in with at least a number 1. More than 1 is better, but at least 1. That means you now have tools in place to try to detect the most frequently or most common types of attacks that are known as of right now. So this is a great tool. Now you may be wondering, well, how do these boxes get filled in? I'll give you an example. Let's go to one of our analytics rules here. So on my analytics rules page, let's take a look at one of these here. Let's pick AD user. Okay, so AD user enabled password not set within 48 hours. If I modify this rule right here where it says MITRE ATT&CK, if you notice there, it has a 2 selected. I've got one here and I've got something else further down. Because I have this box checked, what will happen is at some point, usually within a few minutes to an hour or so, that will also, the box will be checked here also. So whatever type of attack that was, I think it was persistence. So for that one there, it's going to be one of these, which is probably account manipulation. It's one of my 2 schedule query rules. So when you're going in and you're doing hunting queries, let's go back to our PowerShell one from earlier. So when we do hunting queries, when you fill in the tactics piece here, whatever you select here will automatically be added to your MITRE page, within a few minutes to an hour or so. So again, your goal in life is to have something in every one of these boxes that's currently not filled in your production environment. This is how you ensure the best possible force posture. You can't detect undetectable things, 0-day type of attacks or threats, but most threats you will be able to detect. Hopefully you enjoyed this video, and again, as usual, practice in your labs. It's going to help you out. It's going to make you a lot better in what you're doing here. So thank you very much.
In this learning path, We covered threat hunting. We walked through how to perform threat hunting in Microsoft Sentinel using queries, bookmarks, live streams, and the MITRE ATT&CK framework. We looked at hunting tools, using tools such as notebooks, search jobs, and external tools to hunt for threats in Microsoft Sentinel. And finally, we looked at threat hunting hypothesis, how to develop a threat hunting hypothesis that is achievable, narrow in scope, time-bound, useful, efficient, and related to the threat model. This concludes Learning Path 10. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you very much.